Welcome to another video by Team Adcom. In this particular video, we will be discussing a question which is associated with the change in momentum from the chapter Laws of Motion. Hope the video would be useful. If you need any clarification, do let us know in the comment section. So the question is, two identical billiards board strikes on a rigid wall with the same speed but at a different angles and get deflected without any change in the speed as shown in the figure. What is the direction of force on the wall due to each ball and the ratio of the magnitude of impulses imparted to the balls by the wall? So here we need to find out when two billiards balls are striking on the wall. So it is in two cases. One is it is striking the wall normal to the wall. That is the first case. Second case is that it is striking by making an angle 30° with the normal to the wall. So in each case, we need to find out what is the direction of the force on the wall due to each ball, as well as we need to find out the ratio of magnitude of impulses imparted imparted to the balls by the wall. That we need to find it out. So here, when you see, you can understand that there is a statement that is connecting over here. What you need to check now, with the same speed, strike with the same speed, and they're mentioning that there is no change in the speed. They're very clearly mentioning that there is no change in the speed. So we'll take the first condition. In this condition, you can see that the ball is striking the wall by making an angle 90° with the wall with an initial velocity u as well as the final velocity u. So if you take this particular cases, here you can see that the incidence, for example, before collision is in the direction of plus x-axis, after collision is in the direction of minus x-axis. Because if you draw the axes, this is plus x, this is minus x, this is plus y, this is minus y. So the incidence of the ball is in the direction of plus x-axis. After the collision, it is moving in the minus x-axis. So correct. So if you take initial momentum, let it be p. It can have two components, that is momentum along x-axis as well as momentum along y-axis. So if the initial momentum, if you are taking the initial momentum along the x-axis, that is equal to mass into velocity. So mass is m into u, mass into velocity. Then when you're considering the y-axis, there is no motion along the y-axis because the motion is parallel to x-axis. So there is no component of velocity along y-axis. Therefore, py will be equal to 0. So the initial momentum px is equal to mu, py equal to 0. So then in the same way, after collision, if you want to calculate the final momentum, let it be p dash. So that is also having two components, that is px dash as well as py dash. We know that after the collision, the ball is moving in the negative x-axis. After collision, ball is moving in the negative x-axis. That means the p dash of x. That means the p dash of x. That will be equal to m into minus u, nothing but equal to minus mu. There is no motion along the y-axis. That is why the momentum along the y-axis after collision will be equal to 0. So if you calculate the change in momentum, so the change in momentum can also be along two directions. That means delta px, change in momentum along x-axis, that is px dash minus px, that is minus mu, that is equal to minus 2mu. In the same way, change in momentum along y-axis, that is equal to, both the components are 0. So change in momentum along y-axis will also be equal to 0. Clear? So when you're considering it, so we know that change in momentum is equal to impulse. Change in momentum is equal to impulse. What do you mean by impulse? Impulse is equal to the force into the time change. What is this time? That means it is the time at which ball is in contact with the wall. We know that the time gap would be very small. Because of that particular reason, we will not be able to ascertain the magnitude of force. Because when a ball is striking the wall, the time at which the ball is in contact with the wall is very small. The time gap would be very, very small. As a result, we will not be able to ascertain the magnitude of the force. So here what we can write? So change in momentum we have calculated. So what we can write? We can write it that x component of impulse, that is equal to minus 2mu because it is the x component of change in momentum. In the same way, y component of impulse, that will be equal to 0. Y component of impulse, that will be equal to 0. Here you need to understand two important aspects. So the thing is that when ball strikes the wall, when the ball is striking the wall, we can see that ball will be exert some force on the wall. When ball strikes the wall, ball will be exerting some force on the wall. That means force on the wall, force on the wall by the ball, force on the ball by the ball, that will be in the plus x direction because ball is striking like this. So as a result, ball is exerting some force on the wall, that will be in the plus x direction. In the opposite way, according to Newton's third law of motion, force on the ball by the wall, force on the ball by the wall. So how much amount of force will be exerted by the wall on the ball, that will be in the negative x direction. That will be in the negative x direction. That's what you need to understand over here. Done. So that is the first case. What about the second case? Here the ball is striking the wall by making an angle 30 with the normal with an initial velocity of u. So we can have here when we are having the vector. So whenever you're having any vector that is making an angle theta with the axes, we can resolve that particular vector along x-axis as well as y-axis. When you are resolving it, usually vectors are resolved in such a way that it is originating from the origin. That means if you extend this particular vector, this is vector u making an angle theta. Here theta is equal to 30 degree. If this is u making an angle 30 degree mean, its x component will be equal to u cos 30 and y component will be equal to u sin 30. Y component will be equal to u sin 30. In the same way, after collision, it is following this particular path. This particular vector can be resolved into, this will be equal to u cos 30 and this will be equal to u sin 30. So here you can see that this is plus x axis. So this is plus, this is minus y axis. So the both value will be minus. This is also going to be minus. Now we are going to calculate the initial momentum. So when you calculate initial momentum P, that can be resolved along two components, that is Px as well as Py. We can see that the initial component of momentum Px, that is equal to mu cos 30, because this is the component of velocity along x-axis. In the same way, the component of velocity along y-axis minus u sin 30, that is equal to minus mu sin 30, After collision, if you calculate the final momenta, let it be P dash, it can have two components, Px dash as well as Py dash. What is Px dash? The component of velocity along x-axis is minus u cos theta, that will become minus mu cos 30. Py dash will be equal to minus mu sin 30, That means if you take change in momenta, that is delta P, that can be resolved into two components, that is delta Px as well as delta Py. Delta Px will be equal to Px dash minus Px. What is Px dash? Px dash is minus mu cos 30 minus mu cos 30. That means initial momentum minus final momentum, that is equal to minus 2 mu cos 30. What is cos 30? Cos 30 is root 3 by 2, that is minus 2 mu into root 3 divided by 2. 2 and 2 will get cancelled. You will get minus mu root 3, or you can write it as minus root 3 mu. If you consider delta Py, that is equal to, this is minus mu sin 30 because in both the cases y component is negative. So that is minus mu sin 30 final momentum minus initial momentum minus mu sin 30. So minus of minus mu sin 30. Okay. So that is equal to minus mu sin 30 plus mu sin 30, that is equal to 0. Please understand, when you consider the final motion after collision, there when you are resolving it, you will get x component of velocity as minus u cos 30, y component of velocity as minus u sin 30. So the x component of momentum will be minus mu cos 30 y component of velocity will be, sorry, momentum will be equal to minus mu sine 30. Clear? So we got change in momentum. Here we came to understand that the change in momentum along x-axis is minus root 3 mu, y-axis is equal to 0. Okay, we find it out very clearly. That means we can write it as x component of impulse, that is nothing but equal to change in momentum, that is nothing but equal to minus root 3 mu, y component of impulse, that will be equal to 0. Clear? In the same way, here you can understand that force on the wall due to the ball, is normal to the wall along the positive x-axis. That means ball is exerting the force on the wall in the positive x-axis. In the same way, wall is exerting force on the ball in the negative x-axis. So if you're trying to taking out the ratio of their impulses, here you can see that in the second case, the impulse is minus root 3 mu. In the first case, impulse is minus 2 mu. So if you take the ratio, what we can write? The ratio of impulses. In first case, we got 2 mu because we are taking only the magnitude. If you take only the magnitude, 2 mu divided by second case, that is root 3 mu. So mu cancel, ratio will become 2 by root 3. If you simplify 2 by root 3, it is approximately equal to 1 by 2. So this is the ratio of their impulses. Clear? Hope the video is useful. If you need any clarification, do let us know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.